Thank you for the invitation, and thank you so much for the speakers that came before, for both the insightful and original talks and inspiring. We were thinking about this question of crisis versus crisis, and from where we're sitting, it feels a little bit like a choose your own adventure. You can go many different ways depending on how you want to look at this, but one of the things is, of course, we know that there's a bit of a demographic shift coming, more and more people coming to the earth, more and more people moving to the cities. According to the United Nations Environmental Program, we got to double the built environment over the next 40 years. Of course, that looks different in different contexts. It looks different in India, it looks different in China. It looks different in the West. In China, just to bring home the need for materials that this brings, China used as much concrete in 3 years from 2011 to 2013 as the US did in all of the 20th century. Just absolutely mind-boggling amounts of materials used. In Germany, of course, 90% of the buildings that are going to bring us to net zero by 2050 are already here. Yet we're tearing down buildings that are 20 years old, 30 years old, 40 years old to build new, make place for new buildings, and of course new investments. Money needs to go somewhere. Needs to go into new buildings a lot of the time. And that brings challenges with itself. Net zero carbon, which I just mentioned, will not solve this. We're addicted to materials. We're literally moving mountains to build our cities in the West. And so these challenges are intermixed and come together. The waste we create in the built environment is another part of this new construction issue. In Denmark, where these numbers from, the built environment generates 37% of all society's waste. We use about 35% of the materials and spit out 40% of the greenhouse gas emissions. If you don't want to remember these numbers, and I can tell you they're going to be very different for most European countries, you can just remember that we are the 40% industry and not in a particularly good way. So how do we deal with this? How do we deal with the carbon? We're being asked a lot of the time to develop a lot of net zero buildings. The idea is that you bring down your operational and embodied carbon emissions as far as you can, and then you offset the rest, which is also bringing a lot of headaches and challenges. So if we are looking at offsets, The Guardian looked into the voluntary offset market. There are 50 largest projects in that had retired the most credits. 1 credit equals 1 ton of carbon, and found that 78% of those were likely junk. The jury is out on the rest. If you want the peer-reviewed academic version, researchers from ETH Zurich and Cambridge estimate that about 12% of that market is working, retiring carbon. The rest is not working at all. And so here's an artist impression of your CEO when they realize you've been offsetting your project or your portfolio with worthless junk, and The Guardian is calling, asking pointed questions. Regulators are catching up. The EU just voted in January to ban the use of claims that projects have a positive or neutral impact on the environment based on offsets. Countries now have 2 years. Once it's ratified, countries have 2 years to put this in, and that means that the fig leaf that we've been using in the industry for a long time to cover carbon is going to be disappearing. So, crisis versus crisis. Here we are. There's a lot of different crises going on here. They're demographic, they are material, they're environmental, they're regulatory, they're financial, and they're all in together in this hot mess that we have to work with. And I was told when I got here that you had a bit of a rough morning in terms of messaging, and I should instill some hope. I think Sergey and Upame already did a good job at this, but I guess just to add my 2 cents, the bad news is that the built environment is very much a part of the problem. The good news, on the other hand, is that we're such a big part of the problem that we have to be part of the solution. And from where I'm sitting, that's exciting, at least. Turns out architecture does matter. But this is the context that we're working in as architects, and part of this context, of course, is old news, and part of it is new and evolving very fast, and that's what we're trying to navigate in 3XN and GXN. We're a Copenhagen-born office, with local, Copenhagen-born international office, I should say, with local offices in London, Stockholm, Amsterdam, New York, Sydney, and the Amsterdam office servicing Germany. We do a lot of work across different scales, across different typologies, and I'm proud to say we're also working here in Munich. So this is the SAP Arena that will open later this year in September, with Red Bull inviting NHL teams over to play, and then Bayern Munich playing basket the day after. And we've been chosen, together with the OMA, to do the master plan for the BMW Munich factory. And that's something we'll be working on for many years to come in the city. So we'll have a lot of good excuses to come back here, which is great. This is our office in Copenhagen. It's lovely. If you guys are ever in Copenhagen and want to visit us, please just let me know. We'd love to host you and continue the conversation. But I think the thing that sets us apart, and I think the thing that I heard parts of, at least in the German introduction, is this sort of mix of two companies under one roof. We are an architecture company and a research consultancy sharing one building. And GXN, where I sit, was spun out of 3XN Architects to try and deal with some of the challenges that we have been talking about today. Out of the realization that there's a lot of interesting trends, approaches, technologies, challenges coming our way that are very hard to deal with within the traditional confines of an architectural project and business model. If something goes wrong in an architectural project, it goes very wrong, and you might be asking somebody to go out of business. So in that environment, testing out a new material at scale becomes tricky. Testing out a new technology that we haven't proven becomes tricky. And that's basically what we get to do in GXN. We get to do all the stuff the architects don't get to do. We get to play around with new materials. We get to make mistakes. We have been traditionally funded by external research funding, working together with universities, startups, material providers, other people, to try and see what they have might mean for architecture at scale. So this is us. We are the nerds to the architects. We get to get very excited about new things and run fast and get ahead. And we get to sort of really dive in and follow the same problem over and over and over again. And that relationships between the two companies, you could say, is one of experimenting and then scaling. We are trying to figure out what works in GXN and scaling up in 3XN. So just to give you an example of what that looks like, this is a GXN research project, again, working together with the Technical University in Denmark, a startup company called Odico doing the formwork. The idea is using a hot blade to cut formwork for casting double curved concrete surfaces. As you've been told, formwork is expensive, it's costly, it's environmentally heavy. Polyurethane is probably not the best thing on the environment, but the idea is to at least reduce the cost and increase the speed that you can do these things with. And we were working with a company trying to figure out two things. What does it look like to do a workflow where you can integrate this in architecture? And how do we work with the geometry from the architecture side when we are designing? And so working through that, one of the skills that the digital design team in GXN was picking up was how to work with architectural surfaces and geometries, and how to segment it, how to understand it, and also doing that on complex surfaces. And that actually came into play then on a larger project that 3XN did. So this is the IOC, the International Olympic Committee's headquarters in Lausanne. And when it came time to construct this, the engineers were looking at the casting of that little concrete lip that you can see coming down there. And they were worrying about the precision of it. And rather than dealing with that, they had a lot of conversations back and forth. They were actually kicking that back to us and asking, with the model and the knowledge that we had, if we could help do quality control on the construction side and the construction models, which the team could do exactly because they had that skill that they had picked up from research in terms of how to segment and work with complex geometries in this way and exchange data in a way that could benefit the larger project. And so that helped. Here's the building once it was done. There's another interesting story about this. The IOC headquarters was designed with the aim of embodying the values of the Olympics and the IOC. It has this sort of motion of an athlete, or movement of an athlete in motion. But I think nowhere is the idea of embodying the values of the IOC probably more, let's say, tangible than in the atrium of the building, where the central staircase is literally the Olympic rings falling down through the building. Those stairs were designed based on a lot of different things, but part of what was finding its way into that design was knowledge from work carried out between 3XN and GXN, going back and looking at our buildings. So I'm an anthropologist by training. When I first got into architecture, I was absolutely floored when I realized that architects rarely get to see the buildings with people in them. It's an absolutely fantastic thing to think about. Spend 10 years, so much stuff working on something, and there's not really anything in the model that allows you to go back and evaluate the buildings and actually talk to the people. I'm sure people do that and want to do that, but it's not in the business model itself. And so we prioritize going back to our own buildings. We prioritize going to other buildings as well and understand what happens in them. And one of the things we did to get really geeky and nerdy on this, we had a PhD collaboration where a PhD spent 5 years working in the office just drilling in on 3XN staircases, trying to understand what happens on them. 3XN has a saying, stairs connect more than floors, they can become social spaces. through the research of this PhD student, we could indeed see all the different types of social behaviors that were happening there, but also just how important something like the landing was, for example. If you meet somebody on the stairs and you're walking up, you might have to sort of go your own ways when you get to landing if there's nothing there for you to sit on. Stuff like that. So a simple insight that could inform the stairs of the IOC building, where the stairs have been pushed around so that the landing space becomes as long as possible. You need to walk around so you'll meet more people. And where there's these social pockets where you can sit down and actually do something. So I think there's one way of thinking about the work we do between 3XN and GXN. That notion of experimenting then scaling is probably one way to look at it. But back to the crisis. It's not like we haven't been warned, right? This article up here is from 1972. It's a presidential address from Alex Gordon, who was the president of RIBA, the Royal Institute of British Architects. And what he's saying here is he's looking at the parameters that we use to evaluate architecture, saying if you're just looking at cost, capex, you're going to be creating troubles for yourselves down the line. And he wasn't wrong. His idea and his solution here, and you probably heard this, was to come out with the notion of long life, loose fit, low energy. We could add least carbon, high flexibility to that. But this notion of just focusing on cost and industrialization that we also heard has created some challenges. We have a lot of these houses, housing complexes in Denmark, as I'm sure you have here, as I'm sure you have a lot of other places. I have a little bit of a soft spot for social housing projects like these because they came in post-war and actually helped build up the welfare state in many of the countries where this was happening. Creating housing for a lot of people, putting them into these places, making sure people had better options than what was there before. But of course, they also created a lot of problem, and the industrialized way they were built with meant that there was a lot of these buildings being built very quickly. In Denmark, we know now that we're going to have to tear at least 1.3 million square meters of this type of housing down over the next 10 years because it's not working, basically, for various reasons. It's a challenge, and it's probably a shame to tear this down, but it also represents an opportunity. One of the key challenges when we're looking at the circular economy, which I'll get into a little bit, is understanding what is already out in the buildings. We know next to nothing about what is in the buildings that are already out here around us. And within, again, the regular project cycle, we don't have the time to figure that out and understand the quality and understand what to do with it before the building has been demolished. Well, here in Denmark, we know that we have 10 years, 15 housing projects, 1 million square meters that are going to be torn down. And so we wanted to see if there's a way to work with this. We also know when we looked into it that they're all built from the same techniques, the same materials, using precast concrete elements at industrial scale. And so we wanted to do in this research project, do a deep dive on 2 case studies. This is one of them, so it's seen better days, certainly. Figuring out what we could find in documentation, understanding the construction system, understanding the concrete elements, how many there were, what quality they were in, doing testing of the concrete, so testing the strength, testing whether there were dangerous materials. It was strong enough still. There wasn't any dangerous materials. Thinking about it architecturally, if you were to take a building like this apart, what sort of Lego blocks might you get out of it? That's all right. We got to mention, we're from Denmark, we got to mention Lego once in a while. But taking the buildings apart, what sort of blocks might you get out? What might you do with them? We did a design competition then with a couple of companies in Copenhagen. 3XN participated in looking at how you might put these blocks together in new ways, creating new types of houses, new types of systems that could incorporate existing concrete elements. And then we were life cycle assessing it, understanding, what are the actual savings in terms of carbon by doing this. So this is all nice, but of course we wanted to scale this up. We've then been working in another research project with the whole value chain in the construction industry, figuring out what does it mean to actually start by harvesting these things and getting them all the way into the built environment. And so we've been working a lot with demolition contractors. One thing you tend to forget, I think, working with the circular economy is that it's about moving materials from A to B, and sometimes that is the difficult part. We spent 2 years trying to get some concrete elements out of demolition projects. The challenge on demolitions is that you can add cost, but not time. The building has to be down by the time it's down. And so we were standing there with a pot of money saying, hey, can you cut this out for us, please? We want the elements whole. And they're saying, no, it's going to take too long time, but I can probably just, And they were sort of doing that every time we came out, and there would be 3 elements left, and the rest would be broken. But over time, working with some very good demolition contractors and some very open demolition contractors, we were actually finding out that there are techniques that these guys can use, and there are elements in the buildings that can be salvaged, while there are elements they can't do. And so that's being put together now into documentation and guide that can be put out to the industry. And In this specific project here, we managed to salvage 42 elements, walls and slabs, that we were then testing again, of course, and testing new ways of putting them together, different connections. Right now, we're working on 2 use cases for these. So one, which is interesting from an architectural standpoint, means building them in where we're working at it as an architecture office. Another one, which is more interesting from an environmental perspective, is actually working with a concrete material manufacturer, that's a long word, in Denmark, that will be willing to take these back, certify them, and feed them back into a housing project that's actually being built in the area where they come from. But we also tested them out at scale, actually. So this is the new headquarters of one of the demolition contractors from the project. They're called Cherning. The headquarters is you can almost see it, it's sort of a redevelopment of an old industrial hall. And because it's a demolition contractor and one that's very focused on the environment and how to reuse materials, they wanted everything in there to be reused from their demolitions. So 3XN was doing that, and Torben from 3XN will talk much more about that in a breakout session, but one of the things we did was actually build in the concrete elements, the decks, to show that this is possible. You run into a lot of engineers who tell you that they are not going to sign on that line, and that's kind of what we're trying to figure out what to do with now at scale. At a whole different scale, a recent 3XN GXN collaboration is in London. This is 2 Finsbury Avenue. Here we're looking at the existing building on the site. We wanted to avoid situations like this, getting this waste out. We wanted to save the carbon that was in the materials. And so what we're developing at the moment is methods for doing pre-demolition audits, understanding exactly what is in the building, what are the volumes, and then turning that into what we call an upcycling catalog, so a catalog of ideas that you can give to the developer and help them make some decisions about what should happen. One of the things we looked at here was the aluminum. So the existing buildings had a massive aluminum facade, a lot of material going to waste there. Looking at the material properties, starting to develop design ideas with the 3XN team for how to integrate that into the project. Not all were successful. This was it's on a bike ram coming down. We ended up calling it the cheese grater. You can sort of imagine what happens if you have your shoulder hitting that on the way down. We're also looking at lower risk stuff like making the lockers that were needing to be down there with upcycled aluminum, doing wayfinding and so on. So the client was keen to do something like this, but the challenge then becomes, well, what happens if I say yes? So we had to figure that out, and that's kind of what we do in GXN. So we spent some time finding a local manufacturer who could take the material in and remanufacture it, and who was willing to store it. We spent some time figuring out what sort of demonstrators do we need to do to convince both the architects and the developer that this is possible. Spent a lot of time convincing a contractor to get some samples of the building. That was another thing that was surprising. It takes 8 months to get 10 of those off a building for some reason. Having them remanufactured, creating the demonstrators, getting the client out there, everybody was happy, and we could press play on salvaging the materials, which we're now looking to get into the building. What's interesting in London, and I know some of you are going to be talking about policy in some of the breakout sessions, is that they've been putting pressure on developers through this thing they call a circular economy statement, where they're basically asking developers to understand the existing buildings and what to do with them when they're coming into a site. That's really changing the game. Another thing we're seeing in London is that everybody wants the newest buildings, which means that there's a lot of 20-year-old buildings, 18-year-old buildings. Oh, interesting. There's a lot of unloved buildings. And the age for when a building becomes unloved is getting shorter, perversely because everybody wants to be in a sustainable building now. So we're trying to figure out what we can do with the unloved buildings. I'll jump over this because I can see I'm running out of time a little bit here, but I'll show you one example. This is an unloved building in London, in Euston. It's a vacant tower. British Land, who owns it, hasn't been able to rent it out for 5 years. And the idea is to turn this into a new, vibrant loved tower. It's in the Knowledge Quarter in London, so it needs to contain not just offices, but also laboratories, which comes with their own challenges in terms of layout, in terms of vibration requirements, in terms of floor-to-ceiling heights to get all the kit in. All these analysis is something that we can start be doing in GXN. And so this is where we wanted to get to with 3XN on this project, and this is how it looks today. So there's a little bit of space to come. Some of the challenges that we can find through the analysis is understanding, if you look at it in plan, what to do with a floor plan like this. As you can see, it's very hard to do anything other than perimeter offices. It's very tricky to work with these satellite cores. In addition, looking into the concrete and the way it's built, you can see these ripped concrete slabs, which means that the moment you start cutting something, you actually got to cut up the whole rib. which became a challenge when we were looking at servicing. So the rises in the building were incredibly small. People apparently weren't breathing much in the 70s. You could probably blame smoking, I guess. But if you want to have labs in a building like this, you need large rises, and you need to start cutting the floor, and that means you need to cut a lot of floor plate out all of a sudden, and you're losing a lot. Floor to ceiling heights is another challenge here. We went together with partners in London and had a look at whether we could find any buildings rented out with these floor to ceiling heights in London, and we were able to find 2. So there's a lot of discussion that needs to go on with the leasing teams in these organizations to try and figure out what we do, but this is basically a tricky thing. Getting the documentation together for the building is another challenge. There was no drawings, no models for this. So we were working with Arab to get 300 cores drilled out of the building to understand the concrete and the steel. Arab also had to dig 30 meters down to understand where the piles were ending and how well they were performing in terms of figuring out how much extra weight we could put on the site. From our side in GXN, we were doing a lot of analysis of where in the building the carbon was. The interesting thing here is that you can see just saving the foundations and the cores will actually save you about 30% of the embodied carbon that is in a building like this. And then there's a lot of work with 3XN, figuring out how to get this building into something that can perform. I think that, again, this is something that I think Torben will touch on much more eloquently than I do. But I think the interesting thing I just want to get across with this is that the building is not obsolete because of the materials not functioning in the building a lot of the time. It becomes obsolete because it doesn't function as a real estate asset. And so whenever we undertake work like this, we got to take that into account, because it doesn't make sense to spend massive amounts of materials and carbon on getting a building sort of there and then having to do the same thing in 10 years. So a lot of the evaluation that we're doing in buildings like this is also understanding how it performs, how it can actually meet the tenant requirements, ways of doing the stacking and the leasing and so on. And all of these things have to come together to be able to create something that we can hopefully build and provide value. And I think I'll stop there.